Hello everyone, this is Jessica Smith and Michael Schmidt, and we are presenting the UML class diagram.
In order to have a firm foundation to base our understanding of UML diagrams, it is helpful to briefly consider design languages in general. Design language, also known as modeling language, is any graphical or textual computer language that provisions the design and construction of structures and models following a systematic set of rules and frameworks. Modeling language is part of and similar to artificial language. Design languages are often used in the field of computer science and engineering for designing models of new software, systems, devices, and equipment. The context of these modeling languages is primarily textual and graphical. Unified Modeling Language, commonly known as UML, is a popular modeling language that is used to build system and object models graphically.
UML stands for Unified Modeling Language, which can be interpreted as a union of all modeling languages, or at least most of them. Listed here are some of the diagrams including use case, class, object, sequence, collaboration, state chart, activity, component, and deployment diagrams. UML provides a standard for using all of these different kinds of diagrams. For this presentation, we will only focus on the UML standards for the class diagram.
A UML class diagram is a UML diagram that visually represents the structure and contents of a class. As you can see, the UML is made up of three main divisions. The top section contains the name of the given class. Right below the class name, there is a middle section, which contains the member variables in the class. The variable names are followed by a colon, and then the corresponding data type. Data types can range from primitive types to customized classes and collections. The third and final section of the UML contains the various operations performed by the class. This includes the methods or member functions of the class. The syntax is similar to the variables section. The function name is written with parameters, if any, in parentheses. The function is followed by a colon and its return data type. Constructors are also included in this section, but the colon and return type are omitted. You may also notice that each entity in the second and third section is preceded by a special marker. The most commonly used symbols in UMLs are the plus and minus, representing public and private. For purposes of encapsulation, member variables are usually private. Member functions, on the other hand, are usually public, so the client has access to them. But there may also be private methods that focus on the internal logic of the class. Finally, there are other symbols that may be used in UMLs, including protected, package, and derived.
UML class diagrams are most often used during the design process when the developers need to describe how the program will do what it does. These diagrams are very helpful in figuring out how the different classes will look. This can help the developers make sure that they are utilizing good modularization and make sure that they don't have a class or method that does too many different things or has too many different variables.
Next, let's discuss why a developer would want to use UML. First, UML is a visual representation. To understand a program, it is essential to understand what each class object does, the information it stores, and how it relates to other classes in the program. By showing this information in a diagram, it is easy to understand and visualize a program's relationships. Second, UML is very readable. The diagram is meant to be understood by any type of programmer and helps to explain relationships in a program in a straightforward manner. Traditionally, to understand a program, a programmer would read the lines directly. This could be thousands or millions of lines of code in very large programs. Having a UML diagram helps to quickly illustrate those relationships. Also, a UML is reusable. by using a diagram to show the code running in a program. A programmer is able to see redundant code and reuse portions of code that already exist, rather than rewrite those functions. Next, UML is the current standard for programming in object-oriented programming languages. Because it is used as a standard, it is widely understood and well known. This makes it easy for new programmers to step up to a project and be productive from day one. Finally, UML is a powerful planning tool.
One of the common problems that developers can run into when using UML class diagrams is the diagram becoming very complex and messy, especially when the program that they are working on is very large with a lot of different classes. If the diagram is overly complex, it can cause issues with the stakeholders and other people who might get overwhelmed with such a complex diagram with symbols that they may not understand. As well, maintaining a large UML class diagram during design iterations can be cumbersome and time-consuming. Some would say that the delay in creating the software caused by having to create UML class diagrams is a disadvantage as well. Others would argue that the advantages of having a fleshed out design with UML class diagrams far outweighs the cost of creating them.
Now let's turn to an application of UML class diagrams in our periodic trials app. Most of the entities are group defined for classes. Each one of these classes can be defined in a UML diagram. One example is the user class, used to represent individual user data in the app. As you can see, we have defined private member variables, including username, password, first name, last name, education level, and scores. We have also included a default constructor and public member functions. In addition to the basic getters and setters, we have also added functionality to add a new score to the scores array through the addScore method. Finally, the getAverageScore method will return the average of all user scores in the scores array. Two other important entities in our project are the quiz class and the quiz question class, which stores the questions and answers. The basic construction of these classes is similar to the user class. The arrow in the diagram shows the relationship of the quiz class to the quiz question class. The quiz class is composed of an array of quiz questions.
In conclusion, UML class diagrams are visual representations of the actual classes within a program. UML class diagrams are especially helpful when describing how the program does what it is supposed to do. The class diagrams can provide an easily readable and reusable visual template of sorts for the developers when they get into the actual coding. The diagrams can also be helpful in describing the overall design to stakeholders and others who may not have a technical background. On the other hand, UML class diagrams can become very complex and confusing, especially if they have not been maintained through iterations of the design process. Each developer must weigh the advantages and disadvantages of using UML class diagrams in their programs. It would seem that popular opinion describes UML class diagrams as useful, helpful, and necessary in the software design and development process.